Welcome back to another episode of Tidal Flooding Talk, brought to you by the New Jersey Coastal Coalition in conjunction with our broadcast partners at Tri-X 57. We are, moving through fall here, and it's Dan's favorite season, as he said many times before. Dan, my question for you is, how is that soup on Saturdays coming along? Any new soups you guys have on the menu for this fall?
My wife tried we're Olive Garden fans with our kids, not as fancy as I remember it when I was a kid, now that I'm an adult, but she's been trying the Olive Garden soups this fall. So the zuppa Toscana and the pasta fazool, and she's been giving them a run for their money. So that's kind of been the theme of this fall. But love our soup Saturdays, especially with the cooler weather coming in.
All right. I won't comment about Olive Garden because this is a nice podcast, but I'm happy you enjoy the soups at Olive Garden. Yeah, very happy for that. All right. So, we're going to bring on our guest here, a very special guest. We really appreciate his time. He did not have to do this, but I'm glad he's here. Dr. Ramaswamy, he is the director of NOAA's Geophysical Fluid Dynamics Laboratory in Jersey, in Princeton, New Jersey. For those of you who don't know GFDL, this is I would say the research engine of NOAA. They do so much important work in the field of meteorology. This is really a big deal to have, GFDL on to talk with us here. And we're going to talk about atmospheric rivers. But Dr. Ramaswamy, Ram, I know you said he wants to call you Ram. Welcome to the show. We appreciate it.
Thank you, Joe. Really nice to be here and to be with you and Dan. Looking forward to our conversation.
Excellent. And I'll start with this. You've been at GFDL since 1985. You've been there for 40 years. First of all, congratulations on that. That's awesome. Incredible. Yeah, just, tell us, what does GFDL do and why is it important to Americans?
So GFDL right now is actually in its platinum jubilee year. Oh. It's 70 years since GFDL was created back in 1955. And at that time, it's interesting, if I may just go back a little bit to the history, sure, where the mathematician John von Neumann at the Institute for Advanced Study, back in the 50s, when the first 24-hour forecasts were being issued, he asked the question, he was a mathematician, so he asked the question, okay, so what happens if you try to forecast the weather out to longer timescales? And at that time, we weren't thinking of climate change necessarily, but he was just thinking, okay, so if you keep integrating this model, what does it lead to? Does the system settle to some normal behavior? And that started the quest for GFDL as to what happens when you go beyond the 24-hour weather. And so, eventually we got the oceans into the picture, then the land and the ice into the picture in terms of modeling. And so using models, but as well as observations, although we don't do the observations, but using the observations collected, the question is, what can you do with the analysis of the models and observations to get the underlying picture of what the weather systems are like, how the patterns are behaving, how they're changing, what do they do from one place to another? Do they vary seasonally? Do they vary interannually? So that's kind of been the quest of GFDL over the years, and how to get at more and more improved picture of the whole, what we call now the Earth system, consisting of the atmosphere, the ocean, the land, the ice, and increasingly the ecosystem, like fish. How do they all fit into the system? And of course, including human beings. But that's the quest of GFDL. And I think that, computer models are there, but I think more important than just the models is the analysis, which leads you to understand what's happening, because that's fundamentally important, especially if you're going to try to predict the weather, for tomorrow, for the day after, season, next decades, etc.
I mean, 40 years there is amazing, and a lot changes in 40 years. How has your role there changed in the last 40 years, and how is especially the explosion of technology and the explosion, both the accuracy and the availability and the quantity of computer models? How has that changed your role, especially in the second half of that your time at GFDL?
Yeah, I would say, along with the explosion of technology, which obviously has improved the computational power, you're able to kind of do much more computations at a faster speed. But there's also been an explosion of observations. The observations have actually been a very important component of this whole understanding process. The one thing I would say really that's significantly advanced, especially in the last 2 decades or maybe in the last 25 years, is the fact that now instead of talking about just sort of the mean conditions, we actually are able to explore the extremes. So, which are kind of rare, don't happen often. So you don't get that much chance, that much opportunity to understand them because you don't have the observations if they're not occurring. But increasingly, we are getting into, again, with the sort of observations and the computer technology, we're actually able to probe into the extremes and it trace the conditions as to what is causing them or what are the patterns that lead to extremes such as extreme precipitation or even deficit precipitation, and then heat extremes. What is the pattern that governs them, and can we understand the kind of the origins of that? So that's kind of something that has come along very, very visibly in a quantitative manner over the last 25 years, which I think has been very exciting that you can actually now probe these with the models.
Excellent. So, the purpose of why we wanted to have you was talk about the shifting of atmospheric rivers. And you were one of many people who worked on this research project. So, credit to everybody who took this on here. Before we get into that, I understand that Mr. Dong, one of the researchers, along with you, got this idea to study it after his daughter asked if atmospheric rivers can come to New Jersey. Could you just talk about that a little bit? And are there other research tools or things that you guys have done that have come from other kids?
Well, kids always keep asking about the weather, especially if it's very changeable or sort of swings to an extreme, like extreme cold conditions or extreme warm conditions. They always keep asking about the weather because, it interferes with their outdoor activities perhaps, or, makes them pause at something that they're doing. Or sometimes they're genuinely happy that, it's very raining. Or snowing, because then they can go out and play in the snow. So Wenhau's daughter actually posed this question about the atmospheric rivers happening over the East Coast. And, I do remember that Wenhau was actually working on this topic even before, this paper got published. And so he asked the question, hey, what about atmospheric rivers over the East Coast? Because the West Coast atmospheric rivers, are very prominent and have gotten a big banner. What about the East Coast atmospheric rivers? And that's kind of what prompted this study, this analysis, and then which resulted in this paper.
Got it. All right, we're going to take a brief break here. We'll come back on the other side with this episode of Tidal Flooding Talk. Thanks to the New Jersey Coastal Coalition, your flood insurance bills are lower and your streets safer from the reality of flooding. Since beginning in 2013, we build more resilient shoreline communities. Our member towns develop and share in best practices that anticipate future concerns and create flooding solutions. From our town-specific free web app for flooding information to our weekly Tidal Flooding Talk show, we focus on flooding 24/7. Visit www.njcoastalcoalition.com for more.
Welcome back to this week's Tidal Flooding Talk with meteorologist Joe Martucci. I'm Dan Skeldon, joined this week by Dr. Ram Ramaswamy from the GFDL lab in Princeton, New Jersey, talking about changing atmospheric rivers. But before we go any further, Ram, you want to explain what that is? Even as a broadcast meteorologist, I've mentioned it when you have a really prominent one, wreaking havoc on the West Coast. But even as meteorologists, I'd like a little more explanation as to what they are, just the basic background of them.
So the atmospheric rivers, the original thing, it's the nomenclature started, with this, another name given was Pineapple Express, where you had these very large bands of almost like a pipe of moisture flowing in across the large distances in the Pacific. It forms in the Pacific, but then they were being carried in the atmosphere, along with the jet stream, and dumping then moisture as they hit the West Coast, hit the mountains in the West Coast and dump the moisture. But they were actually very tightly confined bands of water carried over long distances. lot of water. I mean, basically, Pacific is full of water, and all the evaporation from the ocean is just tightly concentrated in a narrow stream. And that became called as a river because when you looked at the meteorological maps, that really looked like a river flow. It's very sharply defined in the west. It's not as sharply defined in the east, but there is still a lot of moisture which is actually transported from the tropical oceans, or I think the tropical part of the oceans, and then carried into sort of the east coast of the US. And it can be very varied. The West Coast ones have variation which are probably less than the ones on the East Coast because sometimes you can have a lot of moisture dumped in New England, but a lot of times it's in the southeast that the moisture is dumped. And the sort of uncertainty about, not uncertainty, but the trouble about detecting it on the East Coast is because it actually gets mixed up with other things like hurricanes. For example, hurricanes also bring moisture. They also are kind of spawning from the same systems, tropical systems, but somewhat different, but they can also dump a lot of moisture. And then as the systems move along, there's also a tie-in to the local convection, which can also dump a lot of moisture. So on the East Coast, these three things are almost sort of intertwined, but they do end up forming these bands of very large amounts of moisture. And then when they get kind of dumped, that's kind of what results in an atmospheric river, pouring a lot of moisture onto either the northern part of the eastern coast or the southern part of the east coast. So the name has come to stick because it resembles again a pipe, but it's not as sharply defined as one would see out in the Pacific. Uh, but it still has the same effect of just carrying a lot of moisture.
Sure. And in your research, what are the main drivers? Like, why is this occurring? What have you guys found?
So, there are lots of modes of circulation which drive weather patterns. El Nino, La Nina is, of course, very famous. There's also a Pacific North American pattern, which basically influences the jet stream over North America. And basically, that's when, the Arctic air, cold air, is coming into contact with the warm, moist air from the tropics. And sometimes it can be, they can come very far south, so that influences the jet stream. So that's another sort of mode of variability, typically called the PNA pattern or the Pacific North American pattern. And then there's another one, which is an interesting one, the East Asian summer jet, which subtropical, sorry, it's not subtropical jet, which actually is be very influential in terms of affecting both the west and east coast simultaneously. But these systems are all connected together. They're not like one system acting at a time. They're all acting at the same time. So, but they have different periodicities. El Nino, La Nina has a period of like 2 to 6 years, and then the PNA pattern varies sort of intra-annually, and then the East Asian jet is actually more seasonal. It's connected to the monsoon, for example, so it's more seasonal. But these three are, there are other modes of variability too, but these three we found are the leading contenders in terms of influencing the moisture flow both over the west coast as well as the east coast. And actually, in an earlier study, when Howe actually found out that how the east coast pattern was affected by the PNA, which normally, it was thought that the PNA pattern affected the West Coast atmospheric rivers, but it turned out the same phenomena also affected East Coast atmospheric rivers and precipitation. And then that sort of was a forerunner of this present study, which we are discussing now, which is that the East Coast, frequency of atmospheric rivers has gone up, whereas the West Coast frequency of atmospheric rivers has actually gone down.
So what are some of the impacts that will be seen on the ground of changing atmospheric river patterns? What can we see as a result of these changes, to say in the Northeast or where these changes occur?
Yeah, I think the most significant aspect is the severity of these, and frequency too. But since they seem to be happening a lot more in recent years on the East Coast, the severity becomes very important because they are actually influencing they're hitting a lot of areas which are quite well populated, and so the sort of the whole human ecosystem is affected by the intensity of these systems. So that's kind of the main impact, and then the downstream impact of precipitation and everything else, like agriculture and rivers, flooding, etc. So that is the main impact. It's somewhat different than from the West Coast also has impacts, but I think the fact that these have become more increasingly frequent in the East Coast means that we have to pay attention to how these systems are forming and how are they changing, maybe with time, especially because of the tropical oceans changing, and that then affects the amount of moisture coming in, and then the whole chain of things happening with the rivers forming, and then precipitation occurring in large amounts.
Rama, is this something that you saw in your research is impacting the frequency and or severity of snow in the Northeast?
So mostly, I mean, we haven't yet gone into that as to liquid and solid precipitation. The observations of snow in terms of being pouring out of atmospheric rivers is a little bit scarce. The rain aspect is more, the information is more to hand from these observations, so that is easier to tackle. The snow part is less easy to tackle, but in terms of the precipitation as a whole, the snow is also included in terms of the frequency of and the severity.
Got it.
But less quantitative than the wet precipitation.
Sure. Okay. We're going to take one more break here and we'll get right back. We'll talk more about atmospheric rivers and GFDL here on Tidal Flooding Talk.
Hidden in an abandoned campground in South Jersey lies a mystical encounter with brews and spirits, where bonfires burn, shadows dance, and flavor favors the bold. Ghosts, ghouls, goblins, grown-ups, it's time to reclaim Halloween. This is Witchcraft, October 10th and 11th. For tickets and information, visit witchcraftnj.com.
Hi, I'm Bruce Pascoe. I'm very fortunate. Years ago, I found something that I genuinely like to do, and it's something that helps other people. What I do is help people transition from traditional health insurance into Medicare. I've been doing it here in Atlantic County for more than 20 years. If you're getting ready for Medicare, call me for a free consultation. 609-484-9800.
All right, welcome back, everybody, to Tidal Flooding Talk. We're talking about atmospheric rivers, and atmospheric rivers can cause flooding. Don't let floodwaters ruin your car. Know which streets are prone to flooding and park on higher ground when flooding is expected. And remember, driving through flooded streets is never worth the risk. As we say, turn around, don't drown. All right, Rob. So, we talked about what this means for the East Coast here, with some increase in atmospheric rivers, but, we're talking about a decrease in the West Coast as well. And, when it comes to the West Coast, especially in the mountainous regions and the California Valley, for example, they depend a lot on these atmospheric rivers for their precipitation throughout the year to keep them, going. So what have you seen on that aspect of things?
Right. We've been looking heavily at the springtime phenomena of atmospheric rivers on the West Coast. Very vital because they have to get the moisture in the springtime. And it is very interesting that although the frequency may have gone down, may have decreased in terms of what we see from the observations, the severity is still there whenever these atmospheric rivers hit the mountains. And one thing we found is they're actually, getting back to your question on snow and rain, is that when we consider just the mid elevations or in the mountains, so those get mostly water, and there when you have these extreme seasons, then you get less water, and so it affects the water resource management, and consequently the water supply and everything that water is used for in the West Coast. But interestingly enough, in the higher elevations where precipitation tends to fall as snow, that is not that much affected because there it does precipitate, quite independent of atmospheric rivers, that there does tend to be precipitation there. But that precipitation, stays as snow mostly through spring. It might melt a little bit during summer to add to augment the water resources. So the snow rain distinction in the atmospheric rivers is actually interesting. And we're looking at now more data from especially the higher elevations to see how that has varied over the years. Because what is happening at the higher elevations where it tends to be snow, and what happens in the mid elevations where it tends to be more water, um, they seem to have like a differing tendencies, from year to year. And so we kind of wondering what atmospheric rivers variation from year to year does from one spring to the next spring. What does it do to precipitation falling as snow and precipitation falling as rain? Either way, it is a source of concern for the water resource managers.
Ram, is there any research as to, we always try to forecast the weather. Is there any research trying to forecast future trends in atmospheric rivers? Is this a cyclical thing where the West Coast will go back up? Is there any insight on that? Do you think the current trends you're observing will continue, or is the science not that evolved just yet?
So one of the most interesting things, as I was mentioning earlier, in the last 25 years, is study of the extremes. That has actually led to predicting of the extremes. Like it's a tougher job. Predicting the mean climate is a little bit more easy than trying to predict the extremes. But the one thing again that the observations and models are getting to now is actually prediction of the rivers, and how can we predict them? And so right now we have models at NOAA GFDL where actually we are testing the predictability skill of how far early can we predict the west coast atmospheric rivers. So currently there is, actually indications that one can start looking at this phenomena back in July of the previous year in order to get the predictions out in March and April of the next year. Now, this is not a solved problem. It's going to require a lot of research, but I think it's very encouraging that we are finding the skill coefficient actually increasing in terms of as we ingest more and more oceanic observations, because now all these things come from the Pacific. So as we increase the observations both in the surface of the Pacific as well as the subsurface, we are finding a lot of skill coming up in terms of early prediction of the springtime moisture over California and as well down the west coast, which is very encouraging. It's again, it's a research that is still going on, but it's very promising that now you can actually do these kind of predictions beyond just week forecast or months forecast to actually 3 or 4 months ahead of time. And if it holds, that would be kind of quite a game changer in terms of predicting a season ahead of time.
Rob, you make me think of what I said on last week's Tidal Flooding Talk, which is if you ask meteorologists, do you love the latest and greatest technology? The answer is yes, because we can do things like this. And if we can give early warnings to, or, hey, we're going to see more atmospheric rivers than usual or less to, especially the Rockies and the West Coast, that's important how they can plan their water management, which, if you're in New Jersey, it's something we don't think about a lot, but in the West, that's a very real issue. Before we wrap it up, is there anything else you want to add in regards to this research that you and your team have done?
I think I'd just like to say that, I think this trying to predict these extremes or what we call tails of distributions is a very important quest, both predicting the severity, the frequency, as well as how much early can you predict it. But it's not so, we predict temperature extremes as well, but precipitation is more difficult because it's so inhomogeneous. It's so varying in space and time that it poses really a serious challenge. But, we have initiatives going on in NOAA, for example, there's a precipitation grand challenge. It's called grand challenge because it is indeed a grand challenge. We may get to poke at it maybe, but not solve it completely. But it is something that's being increasingly recognized as utterly important to delve in because of the fact that, there's a lot of damage occurring because of either excess rain or even deficit in rainfall, that we have to know more about kind of how it rains, where it rains, and whether it's changing with time. Is the rain belts, are the rain belts going to move north to northward, or they're going to move eastward? I mean, this is or westward. This is something that is I think a challenge, but I think we've taken it up, and I think that we are seeing some increase in skills compared to where we were a decade ago.
Excellent. Well, Ram, thank you so much for the time.
Thank you.
We appreciate it. You can find more about GFDL's research at gfdl.noaa.gov. We're going to wrap up this episode like we do every week with the one thing we can't stop talking about, tidal flooding or otherwise. Dan, what you got this week?
I got Halloween's coming up, a couple weeks. I can't stop talking about how we don't trick or treat on Halloween anymore. Halloween's a Friday this year. We're trick or treating the Saturday before. I'm a traditionalist. Trick or treating should be done on Halloween. That's what we're talking about in our household.
Is that like a trunk or treat thing you're doing, Dan?
No, that's trick or treat. Every town, like some do it the Friday before Halloween, some do it the Saturday, some do it the Sunday, some do it on Halloween. It's like it's free for all. I think it should be done on the 31st. Just my 2 cents.
Okay. All right. That's fair. You know what? So it's funny because I just lost what I couldn't stop thinking about. So it must not have been that important. Oh, now I remember. Pineapples. So we said Pineapple Express, right? That's the atmospheric river. Something that I don't think many people know is that you can eat the core of a pineapple in the South Pacific where they grow pineapples there. It's very different than the Hawaiian pineapples that we have in New Jersey. Hawaiian pineapples have that hard core. You don't think about eating it. We were in French Polynesia for our honeymoon a few years ago, and they said they can pick out Americans because they said the Hawaiian pineapples have that core in the middle, but the French Polynesian have that soft core, so you can eat right through it. I didn't know that, and now I just can't look at pineapple.
Very interesting.
Yeah. Did you know that, Ram? Is that something?
No, I didn't know that. I didn't know that. That's
very
interesting.
That was some learn something new every day, I guess.
Yeah, I got to try that next time.
All right, floor is yours. Floor is yours. We'll wrap it up with you.
Okay. Sorry.
Oh no, I was just saying, what's on your mind? What's one thing you can't stop talking about, tidal flooding or otherwise?
No, I think I appreciate what you guys are doing, because I think this kind of back and forth talk, as well as the conversation, as well as the topics you are dealing with, I think are very important in terms of just communicating to really everyone as to what the patterns are of the weather and flooding and drought. So I really appreciate what you guys are doing. It's very, very important.
Well, thanks. Yeah, we appreciate that. Go ahead, Dan. I'm sorry. You're the original Tidal Flooding Talk host.
I'm just saying it's the guests that we have, like you, Ram, and like the guests that Joe kind of procures here that kind of makes the show possible. So thanks to you.
Yeah, we really appreciate it. All right, well, we're going to wrap up this week's episode of Tidal Flooding Talk. For Ram, Dan Skeldon, I'm Joe Martucci. We'll be back with you next week with another episode of Tidal Flooding Talk. Remember, you can find new episodes every Tuesday at 7 p.m. But of course, it's 2025, and that means you can see this pretty much anytime, anywhere on our social channels. We'll talk to you soon, everybody. Take care.
Good night.